Hi, let us solve this double integral problem. Evaluate double integral xy into x plus y dy dx over the area between y is equal to x square and y is equal to x. So before we start the problem, first of all, we have to be clear with the region. So let me draw the axis. So I have marked certain points. So based on what? First we will take this between y is equal to x square. So what I can see that this is a curve, not a straight line, because the power is 2. And this is a parabola which is symmetrical about y-axis. Keep this in mind. So if this is y square something, then that will be a parabola which is symmetrical about x-axis. So since it's x square, I'm saying it will come on either side of y-axis. So you'll be having a parabola either like this or this. Let us see which one we have. So if I put x is equal to 0, what is the equation? Y is equal to 0 square, which is 0. So 0 comma 0 is 1 point. Similarly, if you see the second point, that is x is equal to 1, y is equal to 1 square. So therefore, which is nothing but 1, 1 comma 1 is the second point. So for my parabola, 0 comma 0 is the first point and 1 comma 1 is the second point. And I am going to draw my parabola. This is a curve. So you'll get a curved line here, which is of course you will get on either side. Okay, this side we are not interested because it will cut the axis only in the positive side with the line. So why? Because if I put x as minus 1 also, y is minus 1 the whole square, which is plus 1. Okay, so this side also you will get it. So I'm concentrating on the right hand side. So first point is 0 comma 0, second point is 1 comma 1. We are done with this. So now we will go for this equation y is equal to x. If I put x is equal to 0, y is equal to x, so y also will become 0. If I put x as 1, y also will become 1, so 1 comma 1. If I put x as 2 in this equation, then y will become also 2, so 2 comma 2. This is your 0 comma 0. I will use some other color, green. 0 comma 0, 1 comma 1, and then the second one is, for example, if I map to 2 comma 2 again, like that your equation will go. So exactly your equation is going to be like this, of a straight line. Of course the line goes here and goes here also. So now if you notice, what are the common points? 0, 0, 0, 0 are the common points. So this is a point of intersection. These two curves meet at this. Again 1 comma 1, 1 comma 1. This is also the point of intersection. So how to find the point of intersection? If we map it like this, then you can get the idea, or substitute y is equal to x in this equation. If I substitute y is equal to x, then what I will get? X is equal to x square. Okay. In y is equal to x square, if I substitute the place of y x, then I will get x is equal to x square. X square minus x is equal to 0. X if you take common, so you will get x as 0 or 1. So when x is 0, you substitute in any one of the equation. So automatically you will get y also 0. If x is 1, then y also 1. So it means at x is equal to 0 and at x is equal to 1, somewhere this line y is equal to x and this curve y is equal to x square is going to meet. So this is how you have to draw the diagram and mark the point of intersection, which is 0 comma 0 and 1 comma 1. So now we have to set the limits. There are two ways to set the limits. Okay, so this is method 1. I am going to take x along the axis and y along the curve. So if I am going to measure x along the axis, here y along the curve means along y is equal to x square and y is equal to x in this problem. Always, you just keep this in mind, always x varies from left to right side of their shaded region area. always y varies from down to up of the shaded area. So x is left to right means you are going to measure what is the left hand side value, what is the right hand side value, starting from this to this. So if I'm talking about y, I'm talking about from down to up. So what is the lower area, what is the upper area? Okay. So now if I have to fix x along the axis in my diagram, you are going to check where the region starts and where the region ends for x. For example, in this diagram, this is the shaded area I want. Correct? In this shaded region, x is starting from where and ending exactly at 1. So x is left to right. Left side I'm starting from 0. It is, and I'm measuring the width of the shaded area. So length of the shaded area 0 to 1. X varies from 0 to 1. Okay. So I will write x along the axis means x varies from left side we have 0 to right side we have 1. So we are measuring the corresponding distance of the shaded region in the x-axis. Now this is the y-axis. Correct? So in this y-axis, what is the lowest part of the shaded curve? That is this pink line, y is equal to x square. What is the upper part of the shaded line? That is the line y is equal to x. So y along the curve I am going to measure. So I will write y varies from the down curve y is equal to x square to the upper curve y is equal to x. So here I am not measuring 0 to 1. If I measure, so this is also 0. It is like I am not measuring y along the axis. This line I am not checking. If I do that, x also 0 to 1, y also 0 to 1, it is wrong. So x along the axis and y along the curve. Okay. So x is left side from 0 to 1. See here, from 0 to 1. I have the diagram here. So my diagram is like this. So it starts from 0. The shaded area ends here as 1. And y is down curve, that is y is equal to x square, to the upper curve y is equal to x. Now we have fixed the limit, just you have to integrate. So your given question will become, always write the axis value outside and write the curve value inside. So what is your question? Your question is xy into x plus y dy dx. So why I am writing dy first? Because I have written y inside, then first I have to integrate with respect to y, and then I have to integrate with respect to x. So this is for the x. Okay. So for simplicity, we are going to multiply this. So the same question, x varies from 0 to 1, y varies from x square to x. You are going to multiply. Xy into x is x square y. Xy into y is xy square, and then dy dx you will write. Okay. Now I am going to integrate first with respect to what? Y, and then only with respect to x. So your I varies from, I am keeping x as it is. So whenever you integrate with respect to y, wherever x is there, those x should look like constant for you, like a number for you. I have circled the constants. So keep x square as it is because it's a constant, and y if I integrate, I will write y square by 2. Your limit is only for y. Y varies from x square to x. You are going to substitute the limit only for y, and you are going to integrate only y terms plus. And then here x is a constant, I am writing as it is, and y square integration is y cube by 3, and your limit is only from y is equal to x square to y is equal to x. And then already you have differentiated with respect to y, so only one differentiation with respect to x is pending. Now you are going to apply the upper limit as well as the lower limit. So I is equal to, x is equal to 0 to 1. We will simplify first x square. If I apply upper limit 1 by 2, let it be there. X square minus x square the whole square. Upper limit is x. In the place of y, I am replacing x. So x square minus, now in the place of y I am replacing x square. So x square, the whole square will become x power 4. And for these two terms 1 by 2 is there. Plus x by 3 into, again for y I am replacing by x. So I will get x cube minus x square the whole cube dx. So what I have to do, I have to simplify these terms and then I have to integrate with respect to x. Okay. So this is x square, this is x square. So what I will do, I will add the power, still x power 4 by 2 minus, this is x power 2 into 2, 4, already 1, 2 is there outside, x power 6 by 2. This 2 is common for both the terms. Okay. Plus x into x cube, which is nothing but x power 4 by 3, and then this minus is there outside. This 2 into 3, 6. Outside it is 1. 6 plus 1, we will add the power only. Correct? So 6 plus 1, 7. X power 7. This by 3 is common for both. And then dx. Normally what we will do when we multiply, we will add the power. So here 2, 2. So 2 plus 2. Then this is x power 4. X power 4 plus 2. X power 6. So now I am going to integrate with respect to x. If I integrate with respect to x, x varies from 0 to 1. Keep this 1 by 2 as it is. X power 5 by 5 minus 1 by 2. X power 6 by 6 plus 1 by 3. X power 4 if I integrate. X power 5 by 5 minus 1 by 3. X power 8 by 8. So now since I have integrated, I will not write integrate. So I will just apply the limit x varies from 0 to 1. Same way I have to apply upper limit minus lower limit. Now this is simple because wherever x is there I am going to substitute 1. So lower limit is 0. So lower limit you won't get. So 1 power 5 by 10. So 1 by 10. Then 1 by, then this is 1 by 2. Sorry, x power 6 if you integrate, you will get x power 7. I have written wrong. X power 6 is there. If I integrate, x power 7 by 7. So 7 2s are 14. And then 3 5s are 15. Then 3 8s are 24. So if I simplify, I'll get 3 by 56. So this is how we evaluate the double integral. Now the same question, I can change the order by evaluating y along the axis and x along the curve. So now what is y along axis means? I am measuring in my diagram, y always varies from down to up. I have told from down, I am just checking where the shaded region ends. So this is 0, 0, this is 0, 1. So your y is changing from the 0 to 1. So y varies from 0 to 1. So now I have to write x along the curve. What are the two curves that I have got? Y is equal to x square and y is equal to x. So always, this is always down to up, you remember? So I have measured like that. So 0 to 1 I said. So now x varies from left to right, always when to measure. So what is the left side of this pink line is left. What is that? Y is equal to x, which is same as x is equal to y. So what is the left side of this equation? This green line. Okay, this green line is y is equal to x square. From this, what is x? Root y. Okay, so varies from left to right. So x is equal to root y to, when you are writing, see here, the left side of the equation is x is equal to y. That is the pink line. And the right side of the equation is, of course, this equation is y is equal to x square. From that, x is equal to root y. So I can write that y varies from 0 to 1. X varies from y to root y. Since I have written x first, I will write dx and dy. If you solve this also, you will get the same answer, 3 by 56. So always keep this in mind. X varies from left to right and y varies from down to up. So same question, I am evaluating y along the axis, that is from 0 to 1, and x along the curve. Left curve is y, x is equal to y. Right curve is x is equal to root y. Thank you.